And thanks for taking an hour or so here to sit and listen to me talk about some updates that Autodesk has made to the Fusion 360 platform. As Cassie said, my name is Brady Scoffield. I'm an application expert here at IMAGINiT. I've been working about the past 2.5 years or so with a variety of software packages and a variety of clients. So yeah, we will dive right in. First, we'll give a little background on IMAGINiT, and if you've attended one of our webcasts before, you've probably seen this, so just bear with me. What we do at IMAGINiT, we are industry-leading experts, and we provide services for a variety of different solutions. So the first thing we want to do is to discover and understand the problems that our clients and customers have been facing. We want to discover this so that we can recommend the right solution. We then tailor and fine-tune a solution to meet these specific demands, right, through optimization in some of our professional services. And finally, we offer a variety of training and support to help our customers get the most out of their new software packages as possible. Okay. IMAGINiT is just one part of a larger company. We are part of RAND Worldwide. We focus on the Autodesk solutions as well as Leica, Archibus, and Pix4D. Okay, we have RAND 3D, which is the leading provider of Dassault software solutions and PTC training. And then if any of you have taken our training classes, those are written by another company that we partner with, or our sister company under RAND Worldwide, and that's Ascent. And they are the leading Autodesk training materials developer. Also do it for PTC and Dassault. Okay. As you can see here, we've got offices scattered all across North America. I'm coming to you guys from the Boise, Idaho location, and we've got offices spread out through a lot of places. So if there's not one of us near you, we do travel. I know we spend a lot of the fall back on the East Coast, so we can come to you. All right, we also offer a lot of different options regarding our professional services. Everything from consulting, understanding how your engineering department works, and then we offer recommendations to become more efficient. We also offer implementation services for multiple Autodesk solutions, including data management products like Vault and Fusion Lifecycle. Okay, to process automation, where we can code a solution for you within the product or outside the product, depending on what makes sense. We also have a division that takes care of all of our CFD and FEA solutions. So if you have a need for analysis, you can contact us and we can get you helped out. We also have a reality capture division using the Leica scanners to generate accurate point clouds or as-built point clouds for you guys to then import into AutoCAD or Revit or Inventor and use in your modeling processes. Okay. You also see here a number of our training options. We offer in-person, live online, and custom classes. We also have a blended learning, which would be some in-person, some online. And then we have our Productivity Now support website where there's enhanced video learning. I do believe this webcast will be put up there when we're finished. And then you've got technical support from our technical support team. Okay, we've got something hopefully to fit many needs. Okay. We at IMAGINiT are extremely proud to be an Autodesk Platinum partner. We are their largest partner in North America and are their authorized publisher and developer of courseware, right, the training materials that I mentioned earlier. Okay. And under our proven performance, we use our take-aim methodology. Because of our team's combined experience, we know we can deliver every time. We deliver the support that's needed, and we have our top-rated customer satisfaction. And again, some more partnerships that we have, Leica Geosystems for reality capture and Pix4D, and then Archibus. And then we also develop our own utilities for several programs: Civil 3D, Revit, Vault, the Vault client, Clarity, Clarity Security, and Clarity Owner Data Portal. Okay, you can see there's additional offerings there for facilities management. Right, so Autodesk has made a move to these industry collections, right? These are the most convenient and flexible way to access a wide selection of the most essential software in your industry. We'll be looking at the Fusion 360 platform today, which is in the Autodesk Product Design collection. So there are subscriptions available for architecture, engineering, and construction, product design, and then media and entertainment. Right, so you can switch your existing subscription to an industry collection now, and I'd ask that you contact your IMAGINiT account rep for that information. And again, we'll be looking at the product design collection a little bit today. Some current promotions that Autodesk has going on for this quarter. Financing for your purchase with IMAGINiT. And again, these would all be, you need to contact your IMAGINiT account rep to get more information on these. The product design and manufacturing collection +1 offer. Looks like you get 25% off the specialized tools here. And then their subscribe and save deal, which again, you guys can learn more about from your IMAGINiT account rep. All right, so let's dive in here. We're going to do a few slides talking about some of the changes that Autodesk has made, and once we've gone through those, we'll jump into the Fusion software and I'll show you guys the new features. Okay, so what did Autodesk do? Previously, they had two versions of Fusion 360. There was the kind of the basic vanilla version, and then there was a Fusion 360 Ultimate. So they've now combined them into one option. Okay, so all the commercial subscribers get access to all the features that were previously only available with the Fusion 360 Ultimate version. All right, so their goal behind this was to eliminate the need of choosing which, do you want the plain Fusion 360 or do you want the Ultimate, right? Now all of the features are contained in a single subscription price. Right? Rather than having two tiers, there's just now a single software, single version. Okay, so what has become available? Right, all commercial subscribers now have access to the Generative Design Workspace, the CAM Workspace, and then the Simulation Workspace within Fusion 360. And we'll take a look at each of these individually as we go through the remainder here. All right, so for generative design, okay, again, we're going to do a quick overview on the PowerPoint here, then we'll jump into the software and explore it some more. Generative design is a cloud-powered design processing system software. What you do is you set the boundary conditions for your part, right? We'll apply a series of loads and constraints, and then we'll go through and we'll set objectives. Where do you want to maximize the stiffness or minimize the mass of your part? You can set the allowable factors of safety. Okay, and then we can also set the manufacturing methods, whether it's going to be additive or 3 or 5 axis milling. And then once we've done all that, we can run the study, and generative design will develop a number of possible solutions, right? Some of them easier to manufacture, some of them not so easy. And then some of the designs and the shapes get creative. Okay, so we'll dive into this more in just a couple of minutes. You also get access to the simulation workspace. Okay, this is, again, a cloud-powered simulation because everything on Fusion 360 is cloud-powered. And Fusion can do the following. It can do static stress, it can do modal frequencies, thermal stress, structural buckling, nonlinear static stresses, event simulations, which is a preview of that, and then shaped optimization. And we'll take a look at the static stress specifically today. Okay. The final workspace you get access to is the CAM workspace. If any of you have had experience with Inventor's HSM, you're going to recognize a lot of these tools here. So it's 2.5, 3, and 5 axis tool paths. We can do turning operations on a lathe, cutting operations, plasma, laser, water jet. Okay. The software provides tool path simulations to see how the tool is going to look as it moves around your part. We'll take a look at the tool library that Fusion has, and then maybe develop a simple post-process. Right? Fusion comes loaded with a number of post-processors from common machine manufacturers that are already included. All right, so 1 second here, and we will get into Fusion. Okay, so here we've got a simple lifting lug, right? Not a very complicated model, not a whole lot to it. but it'll be a good way to kind of show the different tools that are available. So here we have the lug, right? You can see we've got four, we look down from the top, 4 holes in the top where this would most likely be bolted to some other fixture or some other part. And then we'd put a clevis or a pin or something through this larger hole to lift our load. So we're going to start kind of in the order we did the PowerPoint, looking at the generative design first. So here we have a simplified model, right? Here's the lifting lug itself. Click back, here's the model. And with generative design, without going too far into it, you basically model what you need, right? I tell it that I need to have a shape similar to this up top. I have a body going through the middle here where I'm going to do some exclusions to create a hole through there. And the same with these 4 posts down at the bottom. Okay. So like with all of the other environments and workspaces, with Fusion, you simply come to the Model tab here, and then we click on Generative Design. This is a new location for this, as Generative Design in the past was located up here in the ribbon, and it was a separate software that would open up. They've now basically loaded it native into Fusion 360. So if we click on Generative Design, we can see that I've got a couple of studies already set up here. But let's go ahead and start and set up a new one. So I'm going to make sure all this stuff is hidden, and I'm going to generate a new study. So we've got study 4. I'll show you studies 1 and 3 a little bit earlier, but let's walk through the process here of how to set this up. So the first thing we need to do is to come to this area here, right? We've already got the model loaded. If you want to edit it, we could go into the Model tab or the Model option and change it. But we're going to pick the geometry we want to preserve, like what shapes we want to maintain in our study. So I'm going to select, I want to maintain that shape, and I want to maintain that kind of square base. Once I got the 2 bodies that I want, hit OK, and you can see they go green. So now we're going to select this obstacle geometry, and this will, once we select the things right where we want to maintain holes or some voids in the part, I'm going to select those, and those go red, and these will help to shape the final outcome of the design. Okay, once I usually have this done, I come in here over here and just turn off the visibility. All right, so now I can see those surfaces that I want to apply some constraints and some loads to. So once we've got the geometry picked, again, we're going to kind of work left to right here. We'll say some structural constraints, right? I know this is going to be bolted down with bolts through here. Select OK. We can then apply a load condition. All right, we'll do a force. Let's say we're going to do a lifting force here. We'll change the units to let's do pounds force and say 500. If we come over to our browser or our model tree over here, you can see they've got the loads and constraints in here. We can also expand and see how many bodies were preserved, how many bodies were considered obstacles. Gravity is loaded by default. We can either turn that on or off, and you can, again, just quickly select and change loads as you need. If you could have multiple loads in one study. Okay, so now let's do our objectives. Right, do we want to minimize the mass or maximize the stiffness? So I'm going to do stiffness on this one, and let's say a safety factor of 3.5, and a mass target, I don't know, 5. Right, we won't actually run this study, but we'll take a look at some of those other options. Manufacturing, this tab is a little bit more complicated. Unrestricted is going to basically let it kind of do whatever. Again, generative design is geared, initially it was geared a lot towards additive manufacturing, but they have added the milling options in here. So if we take off unrestricted and take off additive and say, let's do it so it can be made on a 5-axis machine. You could set these to be your tool numbers or tool diameters and sizes. We'll just leave the default values there for now. And then we need to pick the materials. All right, so here, these materials are from the Fusion material library. Right, you could add others if you're working with other ones. To select the materials you want, you simply click on it, drag it up, and drop it in here. And for each different material, you'll see different study results. So we'll do aluminum, maybe a cast iron, and let's find a steel. Close. Right, so now we've got our materials set, our manufacturing method set, our objective set. They've introduced this pre-check, which basically gives you a quick check to see if you've forgotten anything or if anything needs to be added. This one says this study setup has all the information required. We can hit OK. And this is where you would go to solve your problem. Okay, it does require 25 cloud credits to solve. All right, you can see I've got a couple here already done. So we're not going to run this study because it takes a long time, and especially with me streaming the webcast over my internet connection and trying to process this in the cloud, it would bring things to a crawl. So once you have run it and the study's begun, you can go to your Explore button right here. And this will show you the number of solutions based on the studies that you have run. So here, if we look at, I've got study 1, you can see the results for study 1. There's some study 3 results there. And again, some more. And each of these we can click on. So if we look at Generative, this outcome 1. Okay, if you click on it, you take it into kind of a 3D previewer here. All right, we can see that this has got, the 4 bolt holes are still there where I want to bolt this down. And I've got the hole through the middle. Okay, and so we'll look at these status. This is a converged design. It was an organic synthesis method. Okay, what's the material? This aluminum 3003H14 operation unrestricted. There's the volume in cubic millimeters. The mass, you can see this isn't very heavy, only 0.24 kilograms. All right, factor of safety. Okay, so we can see all of these. We can explore and look around the results. Well, let's go back and look at something that's more, traditional design. Let's look at this one. This one looks pretty close to what I was going for. Okay, this one, they say you can do it with 3-axis milling. This one's a little heavier at 1.7 kilograms. If we go back and maybe take a look at this guy here. All right, very similar. And then we can compare a number of these. If we look at the display options here, these are the thumbnails. We can look at different properties of all of these. All right, if we compared this one to, say, this one, I can look at a side-by-side view of these. All right, and then compare the stats by clicking on each one. We can go back. We can also look at different graphs, saying, hey, let's sort on the minimum factor of safety. Or let's check the max displacement for these. So it gives you a bunch of results without you having to take time to model, 9 different solutions and run tests on them. Okay, so once you've done this, you could pick your design and then import it into Fusion, and we could go from there. Again, that process is going to take a while because it's cloud-based, and I'm trying to, we're streaming the webcast here, so we're not going to do that. And we'll just say that we pulled down a design that looks similar to this. Okay, so now let's look at the simulation environment. All right, so we'll switch our model here from model to simulation. Okay, and I've already run one study, right? But this is going to be very similar to the generative design workflow, except that we already have our shape determined and we haven't just told it where we want to hold it down and where the loads are going to be. All right, so we can, all right, if we wanted to run a new study, let's say we'll do static stress, create the study. Let's see, let's simplify. No, didn't want to do that. All right, so the first thing we're going to do is pick materials. Again, these come from the libraries that are built into Fusion. So let's do let's come down and find let's do a high strength, low alloy steel. All right, and again, the constraints and the loads are going to be very, very similar to what we did in generative. All right, let's pick it to be bolted down on these 4 holes. Okay, the loads. We'll do a force load on that surface, change it to pounds force, and type in the same amount there. We could do a quick check and then run the solution. And again, this requires 5 cloud credits to run the simulation study. And I've already got one done, so we'll take a look at the results from that one. So I'll close that. I'm going to come back to, let's see, let's close that. Let's go to study 1 and look at the results. Where'd they go? Okay. Oh, that's not the right one. I can't seem to find my. No, they were there a second ago. Oh, there we go. Just had to make it active. All right, so we can see we've run, if any of you guys have run simulation type softwares before, you get kind of the same issue, the same graphs and displays here. We can pick on safety factor or stresses. You can see where the brighter oranges are where the higher concentration of stresses is going to be, right? Kind of in the corners where it's going to be bolted down. Switch these from von Mises to, various other stresses. Look at the displacement. How much is this going to move? Let's change these to inches. Nope. All right, that's going to move very, very little. 5.587 times 10 to the negative fifth. So not moving hardly at all. Reaction forces, you can see we've got some reaction forces here where it's being held down. And then we can look at the strains on these. So very similar to any other static simulation software, but it's again very convenient that it's packaged right in here with all of the other Fusion tools. All right, so the final tool that we are going to spend some time looking at here is the CAM environment. So again, we're just going to switch from our simulation here to the CAM software. Okay. And again, I've already run through and done a setup, but this one we can take step by step because there's no cloud rendering required. Right? We can do these all, brand new. So the first thing that we do once we get into the CAM environment is we need to do a setup. Okay, so here's the setup. We're going to do setup 3. And the first thing we do is we go through and tell it what kind of operation we're going to do. Okay, we're going to do this in a milling operation. The model orientation is not correct in this case. For CNC machines, the Z-axis is up. And here we've got the model with Y up. So we'll just make a quick change. We'll select the Z-axis and plane. So we'll pick the top here. So now the Z goes up. And select X to be that way. Yeah, that'll work. Let's see, we can also pick our stock point, right? Where do you want the model, the tool to start? Now let's change this here to selected point. Okay, once we get this set up, let's go to the stock. Now, the shaded area here represents the stock material, what this part is going to be made out of. There are a number of options. We can do a fixed size box where we come in here and type in the dimensions. We can do a relative size box where we say, hey, just add, 40 thousandths to either side or so much to the top. So here we could say, let's add 60 thou to the sides, 60 thou to the top. All right, the cylinders, fixed size cylinders here would be for turning operations, same with the tube, or if you have a round shaped part. And then from solid is an option to model a secondary solid that you could then pick for your stock instead of adding in the size. But we'll add the size here. Post-process is where you can give this a program number and comment. All right, it defaults to 1001. You could change that to what you need it to. Comment, we could call it the lifting lug. And then if you know you're going to be doing your offsets, you would adjust those here. Right, so we'll add a 1, and we'll hit OK. And then, so we're going to work through kind of the operations up here on getting these done. I'm going to have my setup 2 here as a reference so I can work the same thing. Before we get into that, let's take a look at the tool library. Right, so it's going to be this icon right here. This will pop up whenever we select an operation, but I like to get things, organized beforehand. So this is the built-in library for Fusion 360. You can see you can have local libraries. Right here, it's got all the tools I've used in this document at a previous point. Okay, then if you work with a certain tool vendor, right, you can search their tools. So here's an Harvey tool. Here's all the end mills that they have. They've worked with Autodesk to get these loaded into Fusion 360. If you're using helical solutions, right, there's a lot of end mills here. You've got aluminum alloys and non-ferrous. They got steels, right, different tools for different materials. Mirror tool, these are the holders. See a big catalog of their holders. Tormach, these would be your cutters, laser cutters, and other tools. Or you could simply look through the library here based on, if you're using copper and you want to use inch tools, or if you're using high carbon steel and you're using a metric tooling. Okay, these are all here. You can also search up top by the different type of operation you're doing, whether you're doing a face or a profile or you're just probing. Right, we pick, probe, hit OK, and then, right, we can see search for a probe tool. And if I hit all right, let's see if we can find. Oh, bad example on the search. But we'll search when we're setting up these different operations. Okay, so the first thing we want to do is a face, right? We always want to cut the top off the material to get the true top of the part. So I'm going to pick the face command, and it's going to bring up our dialog box here. So the first thing we do is select the tool. Now I could say, hey, I know I want to use my 1-inch flat end mill. Well, let's come to all operations, pick a facing operation, hit OK. All right, and type, I want it to be just a face mill, so I'm going to leave face mill highlighted, hit OK. Dimensions, we'll clear that out and hit OK. And then I'm going to pick down here on, inch stainless. Why didn't it bring it up? Let's clear that and go to inch here. And then we can change dimension, let's say a 1-inch diameter. Or you just search it here, 1 inch. And you can see here we've got a 1-inch flat. So that could be used for this one. Facings are pretty straightforward. We don't really need to select a whole lot. The heights should be good. It should automatically cut the top of the stock off and then leave us with the top of our model. All right, so here you can see we now have our toolpath generated. Okay, if we wanted to take a look and simulate this setup with this first operation, you would right-click on setup number 3, hit simulate, and then there are some options we'll go through. I like to see the stock, so I'm going to put a check on stock, and I tend to go with a transparent model so I can see it shaded but still see my part through it. The toolpath, you can have it show the entire. I tend to say just the tail. I just want to see the tool as it goes through where it's going. All right, the info, these will all change based on what we're going on, and we hit play, and you can see it simulating here how the tool is going to go through and remove the material. All right, so if we took it off transparent here and ran it back, you can see it's going to cut away that top little bit of material there. Okay, so now that we've done that, let's go ahead and put in a toolpath to clear all of this excess material around the outside. Something you can do if you already have a setup working, you could come here and we could say, let's copy this one, come down to setup 3, and paste. All right, so I pasted the operation here. It's going to have a little invalid toolpath here. The way to get around this will be to right-click on your toolpath and hit Generate. And it's going to go through and calculate what it's trying to do and develop a toolpath for you. Now let's go ahead and look at the settings here. I'm going to right-click and go to Edit. All right, the tool we've already got selected. It is a, where did it go? Oh, I set it right there. It's a 3/4 inch bowl mill with a 0.015 radius on the edge of the cutter. All right, the feeds and speeds you can adjust. These were calculated from the tool library. The geometry, we haven't really picked anything. We just want it to clear out all of that excess material that we don't need. I did have a check here next to rest machining, which is to remove the remaining stock material. And we set it from the previous operation, which was that face. We don't need to use setup stock because we've already done one operation. I've adjusted this adjustment here to use as computed because sometimes it'll tell you you'll get a message saying that there's too much stock or the stock adjustment has reached its maximum value. Tool orientation. If you check this, this allows you to set your orientation. If you've got a 5-axis head, you can do different orientations. This is where you would do that. We'll do that for an operation further down. But I'm okay with this orientation as it is shown right here. The heights, the heights. Let's look at the heights tab here. By default, the 3D adaptive, which we have selected here, would machine all that it can. I've told it that I want it to stop the bottom height. I've selected it to this surface, so we don't have it cut in the bottom of the outside here. All right, taking a look at these. This is the passes tab. Most of the time, these will be default values. The one I changed the most here is this stock to leave. Here I want to leave 2 thousandths radial or 20 thousandths radial stock, and then 20 thousandths here on this flat surface. The linking tab controls the tool movements, the radius in and radius out, along with other leads and transitions. We'll hit OK, and the toolpath should recalculate quickly here for us. All right, so now if we want to simulate both toolpaths, again, we'll come up to, if you simulate just one of these, it will only do that operation. It won't do what came before it. So when I simulate, I always like to click on the setup, right click and simulate. It will remember your settings from the previous simulation. So if we hit this, let's take a look at the info tab here. You can see the X position is calculated, the Y position is calculated. All right, the different speeds. I have a rapid lead in, now it's a cutting motion, and we can watch this tool go through and remove the material. The coloring here, the first operation was green, the second is blue. That's because I have the color set on operation. All right, we can also speed this up a little bit. Again, we can look at the info and statistics. For these two operations, it's a total of 14 minutes, and we've got 780 inches of machining distance. All right, 2 operations and 2 tool changes. Okay, and it's all set up. Now, to finish, again, if you have these already here, you could copy the rest of these down. All right, if you had them from some other operation or you were doing multiple setups on a single part. So let's just do that. Let's just shift select all these. We'll copy them, click on setup 3, and do a paste. All right, and again, they all have the red little stop sign here saying these are invalid toolpaths. If you want to, you can just click on setup 3, right click on it, and do a generate, and it will generate all of the operations. So it's going to take, the adaptive takes the longest to calculate because it's the longest toolpath removing the most material. So we've got the facing operation, which we did, the adaptive put in, the contour is going to come in here and do a nice finish on this vertical surface for us. All right, we can run through and we'll show the whole simulation here in a minute. We then did a drilling operation. Right, cut the holes through here. Oh, we did forget to get the horizontal, so let's copy the horizontal down. And then we'll drag it up and put it in front of the contour. And then run a quick generate. All right, so the horizontal, the one we just added, basically comes down and finishes this flat surface where those bolts will be going through. Then the contour comes and does the outside of the lifting lug, the part that's sticking up. The drill here, simple, straightforward, drilling through the part. One adjustment I did add to this one is taking the heights and setting up the bottom height to break through the bottom, so we go all the way through the part there. This other drill operation here, this is where we adjusted the tool orientation. So now it's coming in from the side instead of straight down. And we did that by selecting our tool orientation here and then selecting the Z-axis to be along the axis of the hole there. Then we did a final contour to finish the outside. All right, so once all this has been done, you can then go to the post-process. All right, so this is where it converts the toolpaths here to that NC code that your machines will run. Let me bring that over to the right screen. Okay, so here you can tell it, where the configuration folder is going to be. This is where you would select the controller that your machine has. Or we could go with the generic. Let's do the Haas one here. Right, this is where you can adjust some of the post settings, and we'll hit post. And it's going to ask me, hey, where do I want to save it? I'll put it on my desktop for ease of access. Oh, and it's got to install something real quick. So we'll let it do that. And once you've done this one time, you won't have to repeat this whole process. And then it's here. And it'll pop up a new window and bring in your, okay, so this one failed probably because of the additional access control I had on there. Right, so if I picked the correct post, it would generate what I needed. Okay. Oh, another thing you can do with these is you can create a setup sheet within this. Will create an HTML type document. Again, we'll just put it on the desktop. And drag this. Yeah, there we go. All right, and it creates an HTML type setup sheet. Again, if you've used the HSM and Inventor, it's going to be very, very similar. Right, this is customizable. It's an Excel format that you can find in the software files and make adjustments to these. But here it'll tell you, what the part's going to look like when it's finished. Right, here's the stock size, the number of operations. This combined setups 2 and 3. That's why there's a lot of these here. The tool numbers, maximum feed rates, maximum spindle speed, right, and then all of the order of the operations and the tools that are used. Okay. Yeah, so those are the 3 new workspaces that you get access to with this combined Fusion. Hopefully we've cleared up some of the confusion with Fusion. Right now you know that you have access to the generative design, right, where you can put in some basic requirements and then get a shape developed. There's a simulation environment where you can then do a load testing or FEA analysis on your part. And then all in the same software, go from the design to the simulation to the manufacturing, the CAM, right? All right in here. Okay. Cass, do you have any questions come through?